This video is about proving triangles are congruent by side, 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 angle, 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 side, and hypotenuse leg. So remember when we are proving that triangles are congruent, we need 3 sets of congruency at least. Remember that in bow tie problems, we can mark vertical angles are congruent, and in problems with an overlapping side, we can use reflexive property to mark that that side's congruent to itself. So what method, if any, is being used to prove the triangles are congruent? So in number 1, we have 2 sets of sides that are marked congruent already. We have PR is congruent to TR, and we have QR is congruent to RS. Because it's a bow tie problem, we can also mark that our vertical angles are congruent. So in this case, we would have the method side, angle, side. So we can write our congruency statement. So we would have triangle PQR is congruent to, so if we look at PQR, we went from down the side that's not marked to the side with a double tick mark. So our second triangle would be TSR. In number 2, we have 2 triangles that have a side congruent right now and an angle congruent. BD is a shared side between the 2 of them. So using reflexive property, we have a congruent side again. So this would be, again, side, angle, side, because the side is forming that angle. So when we go to name our triangles, the first triangle can be triangle ABD. When you go to name the second triangle, remember that B and D are different angles in the different triangles, so they're not going to be in the same spot. So in this case, the second triangle would be CDB. In number 3, we have 2 sides that are marked congruent. We have a right angle on one side of the line, which means we have a right angle on the second side of the line. We also then can use reflexive property that Q and S is in both triangles. So we have side, side, angle here. Remember that side, side, angle, though, is not a method to prove triangles are congruent, but we do have a right triangle, so we can use HL. So we have a right angle here, the hypotenuse and the leg, so this would be RHL or HL. And then we would say triangle PQS is congruent to triangle RQS. In number 4, we have one set of segments that is congruent. It's a bow tie looking problem, so we can mark vertical angles are congruent. To get our third piece of information, we know that these lines are parallel to each other, so we can use a set of the angles. So depending on which transversal you use, so I'm going to use JN as my transversal. So I have alternate interior angles, which would also be congruent. So J is congruent to N. So here we have angle, angle, and a side that's not included. So this would be angle, angle, side. And we would say that triangle JKL is congruent to triangle NML. In number 5, we have right angles. We also have that AD is a shared side in the triangle, so we can use reflexive property. Again, we have 2 parallel lines on the top and the bottom. So AD would be a transversal, which allows us to use alternate interior angles. So in this case, we would have angle, angle, side. So our method is angle, angle, side. When we go to name the triangles, we have triangle ACD is congruent to triangle DBA. Again, A and D are switching order in the shape because they're talking about different angles. In number 3, AP is a side in both triangles, so we can mark that congruent. So we would have side, side, side as our method to prove the triangles are congruent. So we have triangle CAP is congruent to triangle MAP. In number 7, we have a shared side that is congruent, so TA is congruent. If we look at our parallel lines, we can use the transversal twice to create alternate interior angles. So using the top and bottom side, we have one set of angles congruent. When we switch the parallel lines, we're using the same transversal. So we get a second pair of congruent angles. So in this case, we would have angle, side, angle as our method. When we name our triangles, we have triangle LTA is congruent to triangle SAT. In number 8, we can mark that ER is congruent. In this case, we have side, side, angle, which is not a method. Because this is not a right triangle, this would be none. The triangles would not be congruent.